Everybody, my name is M. Saikiran. I am from ECB section. My topic is Internet Multimedia Traffic Classification from QoS. Introduction. To support the quality of service enable network, the provision and management of robust and automatic traffic classification is critical. As a core part of quality of service enable networks, traffic classification could be employed to identify various traffic categories from the internet service providers to provide differentiated services. However, with the dramatical increment on both popularity and emerging types of multimedia services, it becomes increasingly more challenging to guarantee the quality of service of multimedia traffic. According to the latest Visual Network Index from Cisco, the volume of internet video traffic will account for 82% of all consumer internet traffic by 2022. Therefore, accurate and effective classification of multimedia traffic becomes more imperative. The traffic classification techniques have evolved significantly over the past decades, with the wide applications of techniques using dynamic port number, traffic encryption, and encapsulation. The traditional methods relying on port number and packet payload are not applicable anymore. The machine learning methods have been applied successfully in traffic classification recently. These methods mostly rely on the flow statistics, which enables them to handle both encrypted and encrypted traffic. The classification machine learn algorithms such as random forest and nearest neighbor use the extracted flow features. However, the machine learning based methods heavily depend on the features from expertise and just fit the fixed environments. Once the traffic environment changes, the extracted feature set more likely to be need replacing. This is a classification of quality of service. The first lies in the feature extraction. Normally, the internet communications takes place in milliseconds. To open and close the sessions and transfer the data. Therefore, the online traffic statistics based methods usually take much time to obtain handcraft features, mainly containing two procedures: feature selection and feature extraction. For example, uses the fractal spectrums to realize the fine-grained traffic classification. Although satisfactory results using these methods could be obtained, it needs to select proper spectrum components and has higher complexity when extracting feature set. For more autonomous network management, it is necessary to design an end-to-end traffic classification framework much without much expertise. Additionally, multiple types of multimedia services will emerge in the future. Therefore, it requires the classification systems make dynamic adaptation with the requirements of internet service providers. Changes previous online methods, mostly retain models with the combination of previous data and new class data. For instance, presented a robust traffic classification system which can discover the unknown which can discover the unknown flow of automatically and update system by retraining model with the old and new data. However, this way of learning new class more likely impact the online process negatively, since storing older data will occupy a lot of memory and model retraining also costs us much computing time and resource. To better support new types of services, the online traffic classification framework should be incrementally adapted rather than re-updated from scratch when new types of services appear. However, it is a key issue on how to observe the new knowledge continually over the time, while while retaining the original the new knowledge continually over the time while retaining the original knowledge, namely overcoming the problem of catastrophic forgetting. Motivated by the above considerations, aims to develop a novel scheme for the features to perform online media traffic classification and achieve the class incremental classification combining deep learning techniques, methodology, and implementation of quality of service. The overall framework of our proposed method is present which comprises of three modules, namely the flow representation, extraction, flow presentation learning, and the online classification. In the following parts, we will discuss these models respectively. All experiments were conducted with the Python on a computer running the Windows 10 operating system with the configuration of an Intel Core team, and the overall accuracy is employed as a criterion to evaluate the overall performance of each method. This is a block diagram of the quality of service. Conclusion: as traffic volumes and categories increases exponentially, the traffic classification scheme needs to accommodate the new requirements of feature works. Therefore, integrating the techniques of deep learning, this paper proposes an online traffic classification frameworks for the future networks. The techniques of window sliding is adapted to capture flow slides for extracting features so as to reach fast classifications. Thank you.